Hey guys, welcome to this video. So in this video we are going to see how to control the resource usage in Oracle database using Resource Manager. Okay, so Resource Manager is an internal tool or it's an algorithm which is installed internally, or you can say it is an inbuilt tool in Oracle. Okay, so this is the only way a DBA can control CPU resource. Okay, so other ways are to kill the session which is consuming high CPU, or you can cancel the sequels, right? Or you can just the person who executed the SQL just execute the Control C from his keyboard. Okay, so these are the other ways of controlling the CPU, but this is not a direct method, right? So you are indirectly killing or interrupting some task or job which is running and which is consuming high CPU, right? But you need something which will gracefully limit the CPU. Okay, so that is called capping CPU. So capping is just a technical term which is used in determining the resource manager. Okay, but capping is a simple term. You can take it as a limit, limiting the CPU. Okay, so you can take any real-time example, right? So there is a busy road. Okay, so there are a lot of vehicles which are moving. Okay, so there is one vehicle which is running 150 kilometer speed. Okay, but the limit of the road is only 80 kilometer. Okay, so here the person who is riding with 150 kilometer speed, he may create a problem to others, right? He may dash others, or others may get into some trouble, right? So for that there will be some traffic police to control the person. So he will just catch this person who is riding with 150 kilometer speed, and he will either put a fine, right? So it is this resource manager is similar to that. So you can take the same compare the same example with the Oracle database. So here Oracle database is the road where all the vehicles are running. Okay, so all these vehicles are the tasks, or you can say the sessions which are connected to the database. Sessions which are connected, and all those vehicles which are running, right? So that vehicle which is running on petrol, so those are the tasks. Okay, the person who is riding the vehicle are the sessions, and the one who is riding with 150 kilometer speed, he may be the aggressive session, which means, so here every vehicle will be having some speed. So this speed you can take as the CPU utilization here. Okay, other sessions are consuming less resource, but only one session is consuming. You can take the same example. One session is consuming 80% CPU, other sessions are consuming 20% CPU. So this one session does not need 80% CPU, right? Unless until if that session is a critical, that session is running any critical jobs, you don't need 80% of CPU, right? So in that case, similar to the traffic police, right? So this traffic police, you can take the example as resource manager. He will just say, hey, why you are riding very fast, right? So likewise, this resource manager will cap. It will go and suppress, or it will limit that particular session, saying that, hey, you are crossing the limits, so this is your limit, so you cannot go beyond that. So if you just keep the threshold for any session based on the user, right? So if you set the limit for this user as 30% only, maximum 30% this session can use. Beyond that, if he goes, then resource manager goes and limit it, something like that. Okay, otherwise if there is no control over the resource, then just imagine this aggressive session may still go above, right? Not even you can consider 80%, it can go 90%, and again it will go to 100%. Okay, so when it comes to CPU, if the CPU utilization goes beyond 100%, then there will be a saturation, right? Saturation means every session gets hang, and there will be a lot of impact to the whole database. Database itself may get crash. So here is an example. Okay, we are creating two users, app low and app high. Okay, one user is 20% and another user is allowed to consume 80%. So you can take another real-time example. You can take a banking application. Okay, so this banking application has two applications. One is payment and other one is payment gateway, other one is loan. So here for which application you will be giving app low, and for which application you will be giving app high. So I would be giving app high for payment gateway and app low for loan, because you know that loan will take a lot of time to process, right? So you need to collect the documents, you need to verify the applicant, his financial history, everything, right? So obviously you cannot process the loan in seconds. But for payment gateway, obviously someone who is paying some money online, right? So if someone is buying some product from Amazon or any online websites, and when he goes into the payment gateway, when he enter his credit card number and everything, CVV number, then it has to complete in seconds, right? It cannot take an hour, right? So obviously that may be a very financial highly critical financial risk. So that's the reason giving app high as the user for the payment gateway will be good, because you are allocating more resource for the app high, which means this payment gateway application can use as much as resource till 80% to process the payment transaction. Okay, but you don't need that much CPU for loan, because anyway it is going to take time. Okay, no one is going to rush here. Okay, so obviously app low will run slower and consume less CPU than app high. Okay, so these are the preconditions for using or utilizing resource manager. Since we are a DBA, we will be having access to resource manager. So this is the parameter. Okay, resource manager plan. So this parameter is a main parameter. Okay, so here if you see, by default in your productions, you can go and check in your production system. Okay, so this is a very underutilized tool that most of the DBAs may not, either they may not be aware of, or they may not be utilizing that much. Okay, but this is one of the most important tool that will help you in solving most of the problems in most of the systems. Okay, just because you are not well versed with utilizing these tools. Okay, so obviously for production systems you may need to get more clarifications, right? So you need to understand what all the applications which needs critical which requires more resource, which are critical jobs, and all these details, right? So it's not that possible unless until we stay in a particular project for longer time, right? We need to understand everything in and out so that we can configure the resource manager for those jobs. But when you do a simple mistake, then that will become a huge impact. So that's the reason sometimes we don't touch the resource manager, because when you are capping resource for a very critical job without knowing, then that will become an impact, because when that job requires CPU, right, that job requires almost 70% CPU. Okay, remaining all the other 30% or remaining all the other jobs are not that critical. Okay, but when you cap the CPU for 40%, say for example, for that particular critical job. Okay, so you can take this graph something like this. This is 70% and this is 40%, right? So this job is running and it is consuming CPU until this 40%. Okay, so there is a cap here. So you can take a real cap, something like this. So this cap will not allow this job to further consume CPU. It will just end up over here, and this job goes on throttling the CPU. It will just what you can say. It will be in a stable state, running for a longer time. Right, the lesser the resource, longer the time for the job to complete. Right, so when you have a sudden spike of resource, then definitely the job will complete within a fraction of seconds. Okay, so that becomes an impact. So you should be careful whenever you are using it in production system. So you may see no value for resource manager plan parameter, or you may see something like default maintenance plan. Okay, so default maintenance plan is an Oracle managed plan. Okay, but which may or may not be suitable for every application. So you need to take the pros and cons of each and every applications and compare whether this default maintenance plan will be good or not. Okay, so this default maintenance plan will be allocating certain resource for sys users. Okay, so it's specifically during weekend period. So this resource manager will be mainly used for maintaining the auto task. Okay, so auto task means the automatic statistics job, automatic segment advisor. So all the weekend jobs will be consuming more resource. Okay, so during those times this default maintenance plan may be useful, because this user may be getting the priority. So here we are allocating the resource based on the priority of the application. Right, so during the weekend all the stats job gets the priority, because it may be a non-peak hour and non-business hour. Right, so if you want to disable resource manager, you can execute this command: alter system set resource manager plan without any value, just single quotes without any value inside. So this will be disabling the resource manager. Okay, but if you are setting if you are creating the resource manager plans, directives and resource consumer groups, then obviously you may need to maintain that plan. Okay, that plan will be effective, and you may not be able to, that plan will not allow any other jobs to consume CPU more than a certain limit that you have allocated. So that's why you should be very careful on that. Okay, so I'm just creating two users. Okay, and I'm just granting permissions to the users. Then I'm just creating a table called CPU test. Okay, so already the table is there. So next I'm just creating a resource plan. Okay, so this resource plan, so first I need to log into the PDB. So when it comes to container databases, it is separate. Okay, so for PDBs, the job, the resource manager will be allocated at the job level. But for CDBs, resource manager will be allocated at the PDB level. So if I have multiple PDBs, PDB1, PDB2, right? So if I need to create a resource manager plan for CDB, then this CDB will control the CPU for the PDBs. So say for example PDB1 can consume 70% and PDB2 can consume 30%, something like this. But when it comes to CDB level, right, so which is further deep. So for PDB level, it is kind of a job or user level, user job level. So which user may have which how much percentage of resource, something like this. Okay. So you can create a resource manager. Okay, so here first, whenever you are creating any resource plan, so resource plan, it is kind of a high level blueprint, okay, of how you are going to allocate the resource for the resource manager. I mean, how you are going to allocate the resource for the users, the jobs which are executing with the help of resource manager. Okay, so this is called as resource plan. So it is kind of, if you see, first we are creating a plan called CPU cap plan. So this is the name of the plan because we are controlling the CPU, and we are giving some comment, and then we are giving consumer group. Further, we are categorizing the jobs into consumer group. Okay, so this is the main name of the plan. Okay, under that plan you are just allocating the group. So here consumer group means the high group and low group, like the previous example, app low, app high, right? So similar to this. So low means it will just get less resource, so we will be reducing the amount of CPU resource. High means we will be giving more resource. Okay, so here if you see, management P1 is 20, that's the reason it is low CPU GRP, which is group, and here high CPU group, which is 80%. Okay, so always whenever before we are creating the plan, resource plan for the resource manager, we need to clear the pending area. So here, what is pending area? Pending area is kind of a buffer. Okay, buffer means it is a temporary buffer which stores all the plan information. So there should be some area where all the resource manager information needs to be stored. So the plan information will be stored in the pending area. So before we are creating any resource manager plan, we need to clear that buffer. That's why we are giving this command, clear pending area. So once we clear that pending area, the temporary buffer, then again we will create the pending area. From that pending area we will be creating the plan. So this plan information will be taking space from that pending area. Okay, so now I'm just going to create the plan. Okay, so once we create the plan, we need to submit the pending area. Okay, so now I'm just going to create the plan. Okay, the resource plan is created. Next we need to map the users to the consumer groups. So we already created app low, app high. So but for PDB level we have not created. So let me create it at the PDB level as well. Okay, and also we didn't check the resource manager plan. Resource manager plan parameter on the PDB level. So if you see at the PDB level, we don't have any parameters. It is completely empty. Okay, so this is expected. So by default it will be empty. So we'll be just creating some users on the PDB level and granting the permissions. Next we are going to create the table. So commit is not required, that's fine. So once we create the resource plan, right? So after we plan the resource for the each and every group, consumer group, then we need to map the users to that consumer group. Okay, so this is kind of building some house, right? So first, this is the pending area. Okay, and this pending area stores the information about the resource plan. Okay, so once the resource plan is created, so what we mentioned in the resource plan, the high level the high level consumer group, the plan directive and the consumer group. So here consumer group is the name of the group. So let me give you the hierarchy. First we are creating CPU cap plan. So under that this is the name of the plan. So under that CPU cap plan, we are further categorizing that plan information into consumer groups. Consumer group means it is the consumers, the tasks or the users who are consuming the resource, right? So low CPU, high CPU. Okay, so here similar to this consumer group, you can take another real-time example just for you for remembering. Okay, you can take any telecommunication, any internet provider like Airtel or Vodafone or anyone, right? So even they will be having similar plan similar to these, not plan but their way of categorizing the customers, right? So customers who are premium, right, they may be getting very high speed internet, and customers who are using medium, they will be having medium speed internet, and low paid customers will be having low speed or less data, right? So how Airtel is categorizing these users? So similar to this, this resource manager will categorize the resource. Okay, so after you categorize low CPU and high CPU group, then you need to create a plan directive. So here plan directive is the actual limitation, the threshold that you will be setting. Okay, so for low CPU you will be creating a plan directive of 20%, and for high CPU you will be creating a plan directive of 80%. This is plan directive, this is consumer group, this is resource manager plan or resource plan. Okay, so once you create all these plan information, you will just submit it, which means you are confirming that this is the plan which is finalized to the database. Okay, so next, until this step you have just prepared the plan. Okay, next you need to map that plan to individual users, right? So here if you see this example also, Airtel will first create a plan something like this. So under premium you can take 800 GB because he is paying more money. Medium means it will be 200 GB. Low means it will be 100 GB. Just take an example. So these are the speed of the internet. So they will just create a plan, then they will just allocate the similar to the plan directive, they will just allocate the thresholds, then they will just map it to the customers who are customers who have enrolled for premium, who have enrolled for medium, and who have enrolled for low speed. Right, now we need to map this plan to the users. So high CPU will be mapped to app high, and low CPU will be mapped to app low. So that's what we are doing in the next step. Okay, so after we map the users, that's it. Now resource manager will lock those plans for those particular user groups. So here app low will get only 20% CPU, app high will get only 80% CPU, no matter whatever you execute. Okay, it will not go beyond that. If it tries to, if it reaches the limit, then it will get some events, wait events, saying resource manager CPU quantum. Okay, so now we are going to enable the plan. Okay, so it's not that you just simply need to execute these procedures. So once you execute these procedures, you need to enable it. So the plan, resource plan name is CPU cap plan. So now I'm just enabling this plan to my PDB. Okay, just verify the plan. Okay, so no matter whatever whatever information related to resource manager, right? So every resource manager information will be stored in RSRC view. Okay, this is just for your information. Whatever view that you see as RSRC, so everything is related to resource manager only. There will be a lot of views. If you see, there are almost 76 views related to resource manager, and every view have their own purpose. Okay, so you can check the plan history, the previous plan history of the resource plan that you created. This is the current plan that we checked. Okay, the name of the plan, okay, which is CPU cap plan. So still you get lot of information. Okay, I am just selecting only the plan name, but if you can still go and check other information, so you can get the information about the CPU managed, the instance caging. So let me just show you that. So these are more information if I query everything. Okay, just that's the reason. So if you see, it is for CPU, and instance caging is off, and parallel servers total is 8. So this is the limit for using parallel. Okay, so whenever we are using parallel, definitely resource manager will come into picture, because parallel will exhaust the resource if you are using more parallel, right? So that's why mainly parallel should be properly controlled. Okay, so resource manager will throttle all these session resources. Okay, so you can see the individual consumer group information in RSRC consumer group. So you can see the resource manager session info. So what are all the sessions which are controlled by the resource manager. Okay, so likewise, a lot of informational views are there. Okay, so next you can just run a simple test query. So I'm just creating okay, so yeah, this table is already there. Next time I just need to log in as app low. So I'll just open 2 sessions. So one session for monitoring and another session for executing the commands. So at the same time, log in as app high and run the same query. connect as app high. Okay, so I have not created this table under the users. Okay, so now I am just executing this count of star query. This will be a full table scan. So you can also monitor the session in another different session. So we don't see any output because this query is not that as intense as we think. Okay, so let me just drop this query. Drop this table, and let me increase the amount of data. Okay, still it is not that intense. So let us check the consumer groups. Okay, so it seems that the query is some utilized from some older versions of Oracle, so this may not completely work. Okay, so I'm just manually querying the data. So here if you see high CPU group, low CPU group, and other groups. Okay, but yeah, I have not logged into the PDB. Okay, so show con name is okay. This is PDB only. So currently high CPU group and low CPU group does not have any consumed CPU. Okay, so it is consuming from some other group. Okay, so yeah, I need to log in to the PDB first. Okay. still it is using other group. Okay, so apart from high group, high CPU group and low CPU group, there will also be other group. Okay, so Oracle will categorize the resource consumption based on the usage. So I need to connect to the user. Okay, so I have not connected to app low or app high, so that's one of the reason that Oracle is using on other group. So anyway, let me again create the table. Okay, yeah, so now if you see, when I logged into app high on the PDB, and also when I executed the query from the app high, we got consumed CPU time as 15. Okay, so now I will give parallel. Parallel 32, say for example. So instead of manually connecting to the PDBs and executing manual queries, what I have done is I just created a script, okay, which will just loop all the queries. Okay, first it will connect to app low, and then it will connect to app high, and then it will just execute an expensive query, okay, with the test CPU test table that we created. So it is an expensive join, and also it has almost parallel 32. Okay, so this should definitely cause high CPU. If not, I have another script as well which will consume high CPU. So let us just see. Okay, so how if in case the limit, the threshold of app low is crossed, right? So for app low it is 20%, and for app high it is 80%. Okay, it is not that easy to manually spike the CPU for app high, because almost 80% of the resource is reserved. So we can focus on app low. Okay, so definitely we can try spiking the CPU till 20%, and resource manager will cap the CPU after that, once app low is trying to cross 20%. Okay, let me just execute the script. Okay, so what the script does is, first it connects to app low and execute the query, then it connects to app high and again it executes the query. Okay, so now if you see in $V session we got high parallel sessions. Okay, so actually this is not the exact session, so you should be able to see the session. Yeah, so you can see app low. Okay, so it is just using direct path read. Okay, parallelly there is another session which is running with hog CPU 1, and if you see, this is the main wait event that you need to focus on. Okay, so this is what I was trying to do. So if you see resource manager CPU quantum. Okay, so definitely in your real-time production systems you will be able to see this event. Okay, so if you see this event, then you just close your eyes and you don't need to do any other thing. It is specifically high CPU utilization. Okay, if you see this event, and resource manager is trying to cap the particular consumer group that you allocated based on the resource plan, right? And here for app high, it is trying to exceed the CPU utilization. So even though we allocated 80% of the CPU, but still we could see other group is using other group, which is the sys user, which is also using the CPU hog CPU job. Okay, so I just want some intruder. It's not that only app low and app high should execute on the system, right? So we need some other disturbances as well. So in a real-time system, you cannot completely rely on only the jobs that you are running, right? So hundreds of users would be running some job, and you cannot stop others others in executing the job. Okay, they keep on executing their jobs, and some other jobs may come and execute on the database, and even background jobs also may run, right? So every time databases will be busy. So that's the reason I've just executed a third party job as well, apart from this app low and app high. Okay, so we could see a lot of parallel wait events, and also we will be seeing resource manager CPU quantum if the session is trying to exceed the CPU which is allocated to that particular resource group. Okay, so hog CPU is also having resource manager CPU quantum. So if we see the consumer group, right, so you can also check this $V session or $V consumer group. So let me again open the session. So previously we just tried to manually spike the CPU, but now when we use the job, it is quite easy, right? So this is how a real-time production system will be. So you need to monitor it and take some action. So if you just see the top output, idle percentage will be almost 0. It is 0. Okay, the load average is very high. Okay, so this system is just a VM, so which it has only one CPU. So just check LS CPU to check the CPU information. So threads per core is also 1, sockets 1, CPU is 1. Okay, so these jobs are very resource intensive for this particular system. Okay, but if you go in a real-time high-end systems which has almost 48 cores or 36 cores, then this job is nothing. Okay, so here if you see, there are a lot of parallel flood of sessions are executed, and also idle percentage is completely down. So if you still execute further more jobs, it may go into saturation, so it may get into hang. So now let us just check $V resource consumer group. Name, active session, requests. So you can take any column from this view. Okay, so also we will be checking the undo consumption as well, because if there are any long running sessions, definitely that if that long running session is consuming high CPU for a longer time, then that will become an issue. So you can just check some basic information right from this, and just see how the groups are allocated and how the resource is allocated for each and every group. So here if you see, we have furthermore other name Autotask as well. Okay, Aura dollar Autotask is a background job, right? So previously when we seen, we had only 3 groups: low group, high group, and other groups. But now if you see, there are a lot of subcategories, and each and every group are asking for more requests, and also CPU time, CPU weight, consumed CPU. Okay, and also we need to check the okay, SQL cancelled, switches in CPU time. Execution waiters. Okay, so these are the basic information that you can see. Okay, so we also have some internal job, background group, okay, which is also consuming CPU. So the majority of the CPU consumed, right? So consumed CPU time is the one we need to check. Okay, so if you just take the same query and just order by consumed CPU time, other group is consuming more CPU compared to the different groups which are printed here. Okay, so what is the other group? It is that hog CPU session, this one. This is aggressively consuming more CPU, so that's why we are getting CPU quantum resource manager. And if you see low CPU group, which is app low, the consumer group that we created, right, with the resource manager. So that is consuming almost the second highest, and third highest is high CPU group. Okay, so we can also convert this CPU time into percentage as well. So when we convert this to percentage, we will be able to understand how much CPU that is consumed, right? But this is not the exact value or the sampled value. Okay, so it is just a cumulative value. Okay, so if I just refresh it, it increases, it keep on increasing, because currently the job is active, right? So we cannot calculate the percentile with the help of the consumed CPU time, but there is another way to calculate the percentage of CPU consumed. Okay, so based on that we can understand. Okay, so if you are getting this event, right, the resource manager CPU quantum, so this event is itself is an indicator or a hint that the consumer group, the planned directive, the percentile of CPU that you have allocated is almost reached, the limit is reached. So if I see resource manager CPU quantum weight even for app low user, then the threshold of 20% is reached. It is asking for more CPU, but resource manager will just suppress, or it will just control and throttle the resources, saying that your limit is reached for today, and if you need more resource, you just go and ask your DBA. So DBA will go, DBA should allocate the resource, right? So this is how we can control the CPU utilized for a particular user and the consumer group. Okay, so here I am not measuring any performance for the queries, because this is just a random query I am just executing, right? So if the end user is executing the query from his system, right, instead of this particular shell script, then he will be able to understand what how exactly the performance is. So during that time, if I just allocate 80% for the high use app high user group, then he will be saying, yeah, the performance was very fast, So but the performance for app low was quite slow. So something like that, he will be telling the feedback. Okay, so to disable the resource manager, we can just give an empty codes, okay, with nothing inside. So this will just disable the resource manager, the plan that we had created. So currently CPU cap plan is active. Just say show parameter resource manager plan. Okay, so yeah, for this PDB, resource manager is not active, so I need to use the resource manager plan for this PDB. So alter system set so I have not enabled for this PDB. Okay, so I think I should have enabled for the CDB previously. Okay. So this is not the session for the PDB, so I need to check the PDB. Okay, so even the query also, I mean the place where I am querying is also the wrong place, wrong container. So I need to connect to the, so let me just check the container name. It is PDB. So now just check the parameter resource manager. Okay, so the resource manager plan is CPU cap plan. So previously I just checked in the wrong place. Okay, so the plan is currently active for the PDB. Okay, so this is valid. Whatever that we seen is valid. Okay. Yeah, so we can also allocate the resources at the CDB level, also at the PDB level. Okay, CDB level means, as I already mentioned, the resource will be distributed over the PDB, which are under the CDB. And if it is PDB level, then the resource will be distributed for the users or the consumer group, the jobs that are executing. It will be a deeper level. Okay, so thanks for watching this video. So hope if you like this video and find it useful, just like it and